I will be starting by explaining your final project, which will be released today, and then Luc will continue with today's lab, which is again about text analytics, but this time it will show you how you can use the word embeddings, which is a very powerful way of representing text as numerical vectors. Okay, so I will start sharing my screen to show you the GitHub page and also the project. Okay, so now you can see my screen. So we have a new folder in the repository, which is named as project. So if you go there, you will see I've put the data set there. So we have a training data and a test data, and also we have a project description. So you can read the project description later yourself. I will just explain it briefly. So the project is about, it's actually about prediction of classification of tweets as whether they are about some disaster or not. So the title is Real or Not, NLP with Disaster Tweets. So we have given you a bunch of tweets, and then each of these tweets are labeled as 0 and 1, where 1 shows that that tweet is actually about a disaster like an earthquake or a flood or whatever. And the 0 label means that the tweet is not about a disaster, it's just about some other topic, or it's just something else. So you're supposed to work on this data set and try to use what have you learned so far, and also what you will learn in the coming sessions, in order to improve your accuracy and get the best model possible. You actually use what you have learned in class. So in terms of the models, we want you to only use the models that we have covered in the class, which is so far logistic regression, and later on next session would be random forest and decision trees and the KNN classifier, and these kind of simple classifiers that we have covered in the class. And after engineering, you are free to do whatever you want. You can use the bag of words, or you can use a TF-IDF vectorizer. You're also allowed to use the word embeddings, which you will learn about today. In terms of the models, we'll use and I guess somewhere also in this document. The other important thing is that, so in order to make this project more exciting for you, we have also set up a competition. And throughout this competition, you have the chance to compare your prediction results with your friends, with your fellow students. And the way you can do it is that so we have set up a challenge in the AI crowd. Sort of stuff which was actually launched not many years ago. Okay. Well, wait a second. You'll just lost my screen. Can you see it now? So can you, everybody? Okay, yeah. So this was a startup which was launched 2 years ago. Actually, it's based in Lausanne. So they just provide crowdsourcing solutions to real-world problems, and they have been hosting many challenges. Some of them are actually very popular challenges. You can see some list of their recent challenges here. And we have also created a competition here. So I have put the link to our competition page here. So it's an AI crowd challenges, and the name is final project of the data mining and machine learning course. So as you click on the link, okay, the link does not work from here, but as you click on it, you will be redirected to the competition page, which is something like this. So you can see the name of the competition, final project of the data mining and machine learning. And you can see here that how many days is left until the end of the competition. Before that, make sure to create an account in the AI crowd. So when you just enter the AI crowd website for the first time, okay, no, I'm logged in, but you can basically sign up and create an account there. So I would recommend you to just create an account with your Unily mail address. So that's also easier for us to know you, we can just correspond your account in the AI crowd with your account in Moodle. So as you make an account, you can just go to the project page in the AI crowd, and you can see our challenge. I have also put the description of the project here. So here you have the project description and the data. So you can find the training data and the test data in the resource tab. So here you have a tab which is called resources. If you click on it, you will see that, oh, wait. I have to, okay, wait a second. So as you enter the competition page, there is this participate button here. So you click on participate, and then it shows you the rules of the challenge, and then we require to just enter your university email address, which is basically your Unily email address. You just agree to the challenge rules, and then by click on save, you start to get, you will be participating in the challenge. So here I already have a team, but as you just participate in the challenge, you can, there will be like a create team button here, and then by clicking on that, you can just give a name to your team, and then you create a team and you invite your friends to your team. Just make sure that choose your team name to be the same as the team name that was assigned to you in Moodle. You know, those team names that you have in Moodle that you will choose, I guess, today and tomorrow. And so like Google, Microsoft, and so on. So just take the same name, and then invite your friends in your team, and then you can just submit your result. So you submit your result to this challenge page. And so you only have you only can submit 5 times per day, and this is per team. So when you have a team of 3 people, so you only have 5 shots per day. And and the maximum number of people in a team is 3. So as I said, in the resources, you have the data sets. So we have a training data, which is the data used for training, which is labeled. And you have the test data, which is unlabeled. And you should make predictions on this test data and then make a submission. So make sure that your submission have the same format as this sample submission file, which is here, okay? So if you click on it, it will be downloaded, and then let me open it for you to show what is the format of this sample submission. Okay, just a second. So as you see, it's a single column file, okay? And it only contains the labels 0 and 1 here in the sample. All of the labels are 0. It should only contain 0 and 1, you know, without anything else. So it should be like integers, 0 or 1. And And the CSV file should also contain a header. So here the header is target, but it could be anything. So the only important thing is that it should be a single column CSV file, and it should have a header, and the labels should be either 0 or 1. So if you just have the correct format of your your submission has the correct format, you can just submit your result, and then you will get your accuracy. So, and as you make a submission, you go in a submission task tab. So you just click on create submission, and then you just click on choose file, choose your CSV file, and submit it. And as you submit, you will see your score here. So you'll see that, okay, your submission have been graded, what is your accuracy, what is your F1 score, and so on. So just remember that when you submit, it takes like 1 or 2 minutes for the grader to evaluate your result and compute your grade. So it's not a bug, it's just this platform, just it has an evaluator, and the evaluator usually takes 1 or 2 minutes to just evaluate your submission. And then, of course, you have the leaderboard where you can see your result and compare yourself to the other teams, to your friends, and you can see your rank. So the ranks are based on accuracy. So the team which has the highest accuracy will be in the first rank. Okay, yeah, here I explain how the submission process, okay, and your deliverables. So these are the same content as was in the PDF file. So yeah, and your deadline is on 10th of December at 11:59. And in terms of the grading, you will get a third of the grade from your presentation in the end of the semester in the class. So, and 1/3 of the grade is basically the quality of your notebook, how clean your code is, and if you have explained everything sufficiently. And also another 1/3 of the grade is basically how innovative if you had thought about the grader or about how your results have been evaluated, just contact me. I mean, me and Luc have tested it today. It seems to be working, but still, if there were issues, just contact me in Slack, and we can fix it. Hello? Yeah, it's yeah. I have unfortunately I have an unstable internet connection. No, I hope it's good now. Anyway, I was nearly at the end of my part. Yeah. So yeah, that's it. So enjoy the competition, and I hope this leaderboard and the challenge and the competition among your friends just makes it more exciting for you. Yeah, once again, if you have issues or questions, just ask us. So yeah, that's all. I will stop sharing my screen. Okay, yeah, I can repeat about the grading. So It's actually explained in the PDF file and also in the description page in the AI crowd in your page. So so 1/3 of the grade is basically 1/3 of the grade is basically for your notebook quality, so how clean your code is, and if you have sufficiently explained everything. And the other 1/3 of your grade is basically the presentation that you make. So in the end of the semester, I think in the last session, so every group makes a presentation and present their work and result among other people, like in front of other people. And the last 1/3 of your grade is basically well, we evaluate it based on how innovative you were in approaching that problem. Okay, and and the groups, as I said, are groups of 3 people. Well, I mean, I don't know. I mean, our decision initially was to just limit the maximum number of people per group to 3. And I think as well, at least from the model, it seems that you are 45 students in the class. So we thought that, so with 3 people per group, it will be like 15 groups. So, but maybe if you want, yeah, you can discuss it also with the professor. Maybe we can change it, yeah. Okay, anything else for the moment about the project? Okay, okay, I will update it, sure. Okay, I will update it. Anything else about the project? Okay, if not, so maybe Luc can take over and start today's lab.
Yes, thank you.
You're welcome.
Hello, everybody. Can you hear me well? So we are in week 7. Just check it. Yes, okay. Week 7. And this is the only notebook in week 7 on text analytics. Okay. Okay, so second session on text analytics. I've written here that this is a very, so this will be one of the most difficult lab session of the semester. So please don't hesitate to ask if anything is unclear. I will do my best to explain. But please do not hesitate to ask if anything is unclear. The table of content, I will first recap after giving you some information about the project on Git and GitHub. I will first recap the text representation. This means how we can represent a text, transform it into numbers, into vectors. We saw bag-of-word and TF-IDF. And then in the second part, I will speak about a third way of representing a text, this word-to-vec, and finally a real-life example. We will try to classify financial product complaints using, and we will compare using TF-IDF and doc-to-vec. So doc-to-vec is one of those methods of word embedding that we will see, these new methods that we will see today. Okay. So first of all, about the project, you will have to work with Git and GitHub. And I have here some videos for you if you want to watch them. So this is about Git and GitHub Desktop, and also a cheat sheet. For example, I can show this. You have all commands to manage and create your project using Git and GitHub. And of course, since we do not have time today, but if you have troubles completing your project using Git or GitHub, please let me know by email, and we will arrange an additional lab session or something. If there is a demand for it, we will arrange an additional lab session to show you how to do this. But this should be enough with the videos, and there is a lot of documentation on the internet, so you can find it. Okay, let's start with the recap on text representation. Any question on the project, on the GitHub? Something nothing. Okay. If there is no question, I can start with the recap. I will go quickly on this because this is a recap, and because the time is already we only have 1 hour. So okay, so I import some packages. Genzim will be used for this word embedding parts afterwards. We will also need beautiful soup and request to import data from a website, from Wikipedia. We will handle Wikipedia articles, spacey as last time, and string also, math because we will have to take the log on something. Word2Vec is this model of is this new model for text representation, and of course PyPlot and Seaborn. And I also load the English language model from Spacey. Okay, so text representation. What is this? We have a text, we have a corpus of documents of text, and we cannot use it to feed an algorithm in the row formats. So we have to transform this text into numbers, into vectors, and there are many methods, and we will see 3 of them now. Okay, so some important concepts. A document is some text, so it could be a sentence, it could be a tweet, it could be a book, news article, something like this. A corpus is a collection of documents. So for instance, some articles, a collection of articles is a corpus. A dictionary is the list of unique tokens in the corpus, of unique words in the corpus. And we also have two concepts. A vector is the mathematical representation of a document. We will see this, and the model is an algorithm used for transforming vectors from one representation to another. So let's go with those concepts. First of all, the document. So we know now that we can represent a string with three different quotes, single quotes, double quotes, and triple quotes. This is quite easy. Then a corpus, as I said, is a collection of documents. So for instance, we have this corpus of 5 sentences of 5 documents. And here there is a function simple preprocess. I use this function to preprocess the document, sorry. So to tokenize it from this Gensim library that we will use. So we have the preprocess corpus. So this is a list of lists. So a list of preprocessed documents. For instance, Tom confessed that he had fallen in love with me, and we have all the tokens, and Tom is lowercase So this function made Tom lowercase, and Messent also a bit changed. So document, we have the document, the corpus, and this simple function, simple preprocess. Okay, this shouldn't be so difficult. The dictionary is the, as I said, the collection of unique words in the corpus. So if we take this, we have 36 unique tokens, and we can with this function we have an ID for the token. So if we run this, we have an ID for each token. So dictionary is the list of all words in the corpus. So of all words in all documents. And of course, if a word appears more than once, for instance, the word we, there is only one instance of this here. Okay, any question on this? This shouldn't be so complicated. So yeah, have in mind document, corpus, and dictionary. Okay. Okay for now. Thank you, Pierre. Okay, so one way to represent a text, a corpus, a document, to achieve this transformation of document into vectors, into numbers, is the bag of words. The bag of words is quite easy. You take the dictionary, and for each document, you have one, or you have one if the word is in the document, or zero. And if the document is more than once, you have actually the number of occurrence of the words in the document. So for instance, yeah, I can show you. This is maybe better. So the steps are quite easy. You create the dictionary. So you take all unique words, and then for each document, if the word is in the document, you add one, and if it's not, you don't add anything, otherwise zero. Okay, and I coded it from scratch using Spacy just to show you. So, but I don't know if I have time actually. Okay, maybe just short on this. So this function, you get the tokens from the document using Spacy. So you remove the punctuation and the space, and you return the list of token. And this function, you get the vocabulary, the dictionary of the corpus. So all unique words in lowercase. For instance, if I do this from my corpus above, I will have all the words in my corpus. Of course, for instance, we is only once because I have this. If it's not in word list, I add it. If it's already, I don't add it. So we have a list of unique words in the corpus. And for the bag of words, you get the tokens from the document, you get the vocabulary or the dictionary from the corpus, and then you initialize at 0. And if the token is in the document, for all token in the document, you add 1. So let's do this with the first sentence. The first sentence was Tom confessed that he had fallen in love with me. And if you do this, you will end up with something like this. So you have all words, and we have 1, Tom confessed that, and so on and so forth. So you have one where the words are. So we have, this is the first, this is the representation of the document in the corpus. So 0 and 1 in this case, because there are no words that appear twice in the sentence. And we do this for all documents in the corpus, and we end up with a data frame. I make a date frame of this, and we end up with this representation of the documents in the corpus. So for instance, the third sentence, which was D3, human-caused climate change has caused land ice to melt and ocean water to expand. And we can see that there is twice the word caused and twice the word to, and we can see this here. So to and caused this appear twice. Okay, so it is not so complicated. Okay, remark, of course, this is not perfect, and because we can, for instance, remove stop words. So for instance, to will be removed, I think. Stop word should be stop word. We can also use n-grams. So what are n-grams? Does anyone do not know what n-grams are? And we can also use lemma. Should I explain what n-grams are? Or does everybody know? And lemma, can explain this. Okay, I can explain this. Stop words are words that appear frequently in the language. So to, is, a, such words that are not so useful for the analysis because they are in every document almost. So we can remove them to have a preciser analysis because they don't allow to identify which documents they come from because they're all basically in all documents. N-grams are n-grams are, how to explain this? Two words, for instance, two bigrams is I don't have the word in English, is when you have two words that follow each other. So for instance, if we would have bigram, we would have the token, if I go back, the token, for instance, with me, or if we have 3 gram, fallen in love will be one token, fallen in love, because they follow each other. Tom confessed, if we have, is a bigram. So, and this is useful if you want to represent, because this is one of the disadvantage of bag of words. I come to this here, is that it does not maintain any context information. So for instance, I ate a fish versus a fish eats me. This is a very different, this has very different meaning. But if we represent it as a bag of words, we will have the same representation for I eat fish and a fish eats me. And if we use n-grams, we can figure out which person or who is eating who. And because, for instance, with bigram, this will be I eat, or a fish eat. This will be the token that we will look for in the sentence. So not only words, but 2, 3, 4 words that follow each other. And lemmas are the one representation for different form of the same word. For instance, we have has and had, and they are both from the verb have, and we want to have them together because they have basically the same meaning. Or for instance, happen, happening, happened, or for instance, run, runners, run, runner, and so on and so forth. So lemma is for the same word that have the same meaning. We want the same token. Okay, and we can use the count vectorizer from sklearn as shown here. So this is more easy to use packages than to code it from scratch. And we end up with basically the same. This is not the same order, but this is the same. So we have this vectorization of the documents. So for instance, the third one we had twice cost and twice to, and we end up with the same. Okay. Any question on bag of words? There is one question. Okay, David N is asking me, what's the policy for groups of 4 for the project? I don't really know because I'm not responsible for the project, but this will be clear afterward. I think you can ask the professor, or you can write the other teaching assistant. I'm not responsible for the project, so I don't really know. I knew it was 3, but I don't know for 4. I don't have any idea. Okay. Okay, the advantage of bag of words is that it's easy to use, easy to understand, and that it can bring good results depending on the application. And the disadvantages are that you end up with really big matrices. Imagine you have 1,000 articles and each words, and you use also bigrams, trigrams, then you end up with very, very big matrices. As I said also earlier, this does not maintain any context information, so this won't do the difference between I eat a fish and a fish eats me. And also half solution, we can use n-grams or specifying other parameter. I refer to the documentation. You can look at it on your own. Okay. Okay. TF-IDF. TF-IDF is basically the same as bag of words. So you take all words in the corpus and you put numbers for words that appear in the document. But instead of only adding 0 and 1s, you do something that brings more information. And what do you do is that you underline, you emphasize words that appear in few documents in the corpus. So you put a floating number, and the idea is to emphasize words that appear many times in one document, but also few times in documents in the corpus. So few times in the corpus. Why do we do this? We do this because a high value means that the words will be useful to identify the documents in which we are. If all documents have the same words, the same word in them, the word won't be useful to identify the documents. So we won't be able to identify. So we don't want the word to have a high value. So basically, two things: the temp frequency. So this is the number of occurrence in a words in documents. So divided by the total words in the documents. So this is greater if words appear many times in documents. So this is basically almost the same as the bag of words. And then we have the IDF, which is the log of the total number of document divided by the number of document containing the words. And this makes this this difference. So this is greater if the word appear in fewer documents, because the word will be then useful to identify the document in which it is. So we want it to have a higher value. Okay, any question on the concept of TF-IDF? So basically the same as bag of words, you add floating numbers, and if the numbers is closer to 1, it means that it is more useful for the analysis than closer to 0, or more useful to identify the document in which it is. Okay, no question. So I also coded it from scratch. So the term frequency, for instance, of the third sentence, we have cause that appear 2 times. So we have 0.13 and 2 also. So also 0.13 and the other word appear only once. So we have 0.06. So basically this is the term frequency. So the first part of the TF-IDF, the TF part, this, okay. And now the IDF part, so I can, for instance, and comment this to show you. So of the corpus, for instance, we see that Tom appeared twice in the corpus. He appears, if I print the corpus, it will be maybe more easy. So Tom appears twice here and here. We also, and that's why they have 2. We appears twice and the other word once. So that's why we will have, for instance, or Tom and we will have a lower value because they are not alone. And if we have the word Tom, we do not know from which document it is, but the word confess, we are sure that it's from the first document, for instance. So it should have a higher value because it's better to identify the document in which from which it comes. Okay. So this was for the IDF, and if you do the TF-IDF, you multiply TF and IDF, and if you do this for a D3, for instance, for the third sentence, you end up with those values. So for instance, we can see that the word cost is useful to identify this document because it appears twice in the document, so it has a higher value. And for instance, the word climate or change have lower value because they appear both in this sentence, but also in the fourth. So they are not so useful to identify one sentence over another. That's why they have a lower value. Okay, and of course, you can do a data frame with this. Okay, it does the computation. And of course, you also have this TF-IDF vectorizer from sklearn that you can use. If you don't want to code it from scratch, it's better. And you can also specify the stop words, for instance. You can specify a lot of things. And if you look at the difference, it's basically the same. So 2, yeah, 2, I already explained, so why 2 is higher. It's because it appears twice in the document, and also why, for instance, width is lower because it should happen more than once in the corpus. So once here and once here. Okay. So we use the TF-IDF in the project. If you want to use it, use the TF-IDF vectorizer. Don't do it from scratch, of course. But this was to show you a bit what it does. Okay. The advantages of TF-IDF are the same than bag of words. This is easy, and on the top of that you have these floating values that add a certain information, and which is good for to run an algorithm based on this input then, because it's a better representation than the bag of words. And the disadvantages are also basically the same, so a lot of zeros. So imagine you have 1,000 articles. It does not maintain any context information. You don't know if you eat a fish or if a fish eats you. And of course, we have half solutions, so n-grams. And I refer to the documentation for all parameters that you can tune in this case. Okay, any question on TF-IDF?
Yes, I have a question. Can you hear me?
Yes.
Okay. So what are the numbers in the table, the data frame when we use the vectorizer? Because when I look at the difference between the data frame we created from scratch,
yeah,
the numbers are different.
The numbers are different, that's true, but
Yeah.
the idea is basically the same. I don't know how it works. Maybe it normalized the stuff before, but basically the idea is the same. If you look, for instance, what I said, what I said, the word two, we know that two appears twice in one document and not in the other. So it is very useful to identify this document. And if you see in my, it has a higher value than everything else, so 0.21. So it has a high value compared to the rest. And in the from sklearn, it has also a high value, so a higher value than the rest. So basically, it's the same, but like multiplied by a factor of 2 or 3, because it does not exactly the same as I did. You can see in the code if you're interested how do they do this, but the idea is the same. And for instance, we had the word width. If you see my representation of width is 0.09 and 0.15, and in this case it's 0.27 and 0.36, and it's 15 is like average, so you have a value higher than this and value lower than this. So 36 is the same, you have a value higher than this, 46, and also value lower than this, 27, and so on. And 27 is quite low in this case, and this is also quite low in this case. So if you know what, if you understand what I mean. Does it answer your question?
Yes, thank you.
So I don't know exactly how they do this. Maybe a normalization, maybe I don't know. There is a question, Diana Koka, what do you mean by half solution? Yes, because if you use, so this is on the disadvantages here. So half solution to this problem of context information. So if you use n-grams, so basically half solution of those two problems. So if you specify the min and the max, specifying the min df means that words, it will only count words that appear what you specify times in the corpus. So if you specify, for instance, 10, all words that appear lower time than 10, so 9, 8, only once or something like this, will not be in the bag of words. So this is a half solution to the problem of a lot of zero, because this will reduce the dictionary. It will only count words that appear more than min-df or less than max-df. And this, for the second, to use n-grams, this will provide a solution to a half solution, I would say, to this context information, because if you use, for instance, bigrams, you will be able to recognize I eat and not versus a fish eats, and not, you will be able to differentiate those two sentences if you use n-grams. So n-grams, you can have a bit of context, and specifying min-df and max-df, you can then reduce the size of the dictionary and the size of your matrix. Does it answer your did it answer your question? Okay, any other question on TF-IDF? Okay. So, word embedding now. This is the third way. So we already saw bag of word and TF-IDF. We have a document and we want to make a vector of it. And the third way to do this is called word embedding. And basically the idea is that you will, as it's written here, so you will project the words in a vector space, such that similar words that have the similar meaning will have a similar vector representation in the n-dimensional space. That's the basic idea. So the underlying assumption is that two words sharing similar context, they also should share similar meaning, and they will have a similar vector representation in the n-dimensional space. So n is the dimension of the vectors. You can specify this. And there are two word embedding methods, word2vec and glove. And we will use word2vec. And for example, if it works, it should give you approximately this. This means that if you take the vector representation of the word king, and you remove the vector representation of the word man, and you add the vector representation of the word woman, you should end up with something similar to the vector representation of the word queen. And as a second example, you have a dog, puppy, and pup that should point in the same direction in the space, because they have similar meaning. We can watch a video. This video, I found a video that explains it very well. We can watch this. I think it's 8 minutes. We can watch it, and it's based on, we will see this is based on neural network. So basically, the weights of the neural network, it is just with one hidden layer, and the weights of the neural network are the vector the vector points. So we will see, you will see this in the video if it works. Okay. Okay, you can't hear anything. How should I do this such that it works? What I can do is I can show you the link. No, not in private, but to everybody. And maybe in the settings. It's not here. Oh, wait. Yeah, I don't know how to do this. Yeah, I also think watching by yourselves is also good. So I let you 10 minutes until 25 to watch the video, and then we can go go on. Okay, so 10 minutes to watch the video. And I think it's better so that you can watch on your own and you have the better quality. Okay, see you in 10 minutes. Okay, you should be done. Okay, so the basic idea is to remember not the math, not everything, but the basic idea is to remember that yes, similar words that share this a similar meaning will have a similar vector representation. Okay, and I will now illustrate this. So I have here a function to get a text from an URL. So from Wikipedia, I will take the machine learning article and the artificial intelligence article. And if I do this, I get the machine learning. So machine learning is the study of computer algorithms. So this is the article of Wikipedia. And for AI, it's the same. Artificial intelligence is blah, blah, blah. So we have those two articles that we want to analyze using this word2vec. So this word embedding. So I group them into a list. This is very important. We should have a list of token. I will come back to this later. So this is our corpus of text. So we have two texts in our corpus, two documents. I have here a tokenizer function. So I clean everything, I make everything, I take the lemma, I convert each token to lowercase, I remove the stop words and the punctuation as we did last time, and I also remove the suffix like this, and this because it didn't work otherwise. And then I return a list of clean token of those two texts. If I do this, so for text in text, I have my my process text. I use this function to process the text. And if I do this, I end up with the tokens. So machine learning, study, computer. So it removed the punctuation and the stop words. It made everything lower, and so on and so forth. So we have a list of tokens clean. Okay, and we use the word2vec from Gensim. And we have to pass, this is very important, a list of token. Because if you only pass just one list, for instance, this one, this will do the analysis on the characters, on each character. And we want to do the analysis on words. So it should be a corpus of documents, and the document must be list of token. So a list of token, a list of tokens. Okay, so we use this class. The min count is the same as the min_df that I explained before. This is the minimum number of occurrence of single word in corpus to be taken into account. And we also specify a size of 100 for the vector. And if I print the vocabulary, so the dictionary, we have the word machine learning, ML, study, and so on and so forth. And we have, for instance, the word intelligence, and we want to see its representation, and we have the coordinates of this vector. So the size is 100, and this is, for instance, the vector representation of the word intelligence in based on the text I gave the model. Okay, and what is very interesting is the similar vector, the similar words. We can see the most similar words of a word, in this case intelligence. This is the cosine similarity that you've seen in class. And if I run this, we have the 10, I think, 10 most similar words to the word intelligence. So we have AI is very similar with 0.95. Human machine use artificial so it's in this context that we have those words that are similar. This is in the context of the input I provided. So human machine use artificial, of course, because we have articles on artificial intelligence, learning, and so on and so forth. And we can also see the similarity between two words. For instance, between computer and animal, the similarity should be quite low. That's the case, 0.29. And between computer and machine, in this context of machine learning and AI, this should be quite high. And this is also the case, 0.92. So similar words share similar vector representation. We can see here that computer and machine are more similar than computer and animals. So they point in, if you would have this in 2 or 3 dimension, the vector would point in those two vectors would point in the same direction, and those two in basically not opposite but not the same direction. So okay, any question on word to vec? If there is no question, I have an exercise. The professor asked me to give you an exercise for the participation grade. So you have to do basically the same as I did here. So you take an article on a coronavirus, and then you compute similarities of words, and you can submit this to me. Basically, I have to make group of 3 people, but I don't know how to do this. Maybe this. No. Does anyone knows how to group people, to make the rooms of people? Okay. Breakouts. Make me ask and I can do it. I don't know if it's possible. Breakout rooms, but where it is. Down. Maybe if I stop the screen share. I don't find it. I can make you host, but I don't know either. I don't know how to make you host. Le noob. Yes, maybe only Ahmad can do this because I'm only co-host, I'm not host. But anyway, you can do the exercises alone. And this is breakouts room. I will try this. But you can already start to do the exercises maybe on your own. And you have to submit it to me on Slack or via Zoom in private, and this will improve your participation grade if you do this. So this is the professor asked me to do a bit of exercise. So basically, you have to do the same. You get the text from coronavirus on Wikipedia. You use the Spacey tokenizer, and what is the number of occurs? There is one question, and then you create a vector word-to-vec representation, and then you compute the 10 most similar words of virus. So you can follow the steps above. And I give you like 10 minutes because we don't have any. The deadline is like you have to submit it today. If you don't have time within the 10 minutes, it's not a problem. You have just submit me something, and yes. So deadline is like today evening. Okay, I will try to do this for next time to break out the rooms.
Hello. Hi.
Yes. Do you have any question?
Yeah. Sorry. I mean, in the you have the two texts, right? The machine learning and the artificial intelligence.
Mm-hmm.
So we have only one coronavirus, right?
Yeah, and you have that's what I mentioned earlier. You have to. This is here in the step 4. You have to make a list of your vector representation.
Okay.
So you have a list of token. So
Okay.
if you do this, you get a list, and you pass the you can pass the in the word to vec, you can pass the first argument as a list. So something like this, processed text. You have to make it a list because otherwise it doesn't work. And it took me 1 hour to figure out as I did the assignment, the lab session. What should we put in the spaCy tokenizer function? You have to first get the text. And once you have the text using the above function, you have to tokenize it. So you pass the text as a string in the tokenizer. So the raw text on coronavirus. Okay, I think I have to continue because otherwise we won't have time to finish this, and this is the best part, this classification part. Pierre, the resulting variable of the text I can show you. So the getText function basically takes an URL as input and return the article. So you get the text, from this URL, and this you put in the spaCy tokenizer. So you will get a coronavirus. So you get coronavirus equals getText HTTP Wikipedia blah 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 coronavirus, and then you tokenize the coronavirus. So you have your processed coronavirus text, and then you vectorize it, you pass it as a list. So you, because you have to pass it as a list, so you have your processed coronavirus here, you specify the args, and then you answer the question. Okay, but you have until today evening, until, I don't know, until today, until tomorrow, until. So you have today evening to finish this and to send it to me, to send me your code, and this will be fine. The professor just wants to assess the participation this way. So okay, you will get points for participation if you do this. Okay, the most interesting part is now. We will classify complaints. I will just answer the question from Pierre. Then we can go above 10% of participation. I don't know. We will. I think you get just 1 point per week. So this is not much. He told me you have to give 1 point per week, or 5. No, I don't. No, 5 in overall. So 1 for each lab session. This will be in the future lab sessions as well. But I don't know if you can go beyond 10%. Okay, so we want to classify complaints. We will see this in a moment, and we compare TF-IDF and doc2vec. So doc2vec is basically the same as word2vec, what we just saw, but for documents, just not for words, but for documents. And we also use logistic regression in both cases. So the only thing that changes is the way we prepare the text, the way we turn the text into numbers. So we use TF-IDF and doc or doc2vec, and we compare those. So I have the data on the GitHub. We can see we have a date, a product, and a text. Where is the text? Complaint narrative. Here we don't have but here we have null values in this case, but there are some non-null values for which we have a text, and we want to predict the product. So we have a complaint with a text. This is not a very good example because we don't have anything. But if I have a sample, or maybe 10, so we see that we have the text, and we want to predict which category it is. That's basically the idea. So I want to predict the product based on the text of the complaint. So we just select those two because we are only interested in those two, and it results in a data set that have around 2/3 of the complaints are null. So we want to remove them, we drop them, and we end up with 3,000, more than 3,000 complaints. This is not a lot compared to the whole data sets. The whole data set is like 600 cleaned. The whole clean data set is like 600,000. 600,000 complaints, but because it took too much time to run, I only selected a part of this, a small part of this data. So this data is real data that comes from data.gov websites. Okay, so, and if I clean this, we have the complaints, and we want to predict the product category. So a bit of exploratory descriptive analysis. for instance, the total number of words. So we apply with splits based on the space, and we do the sum, and we end up with 600,000 words around. And for example, one complaint is, this is an example of a one complaint, and we can see that the data has been anonymized. So the names, the dates, and so on and so forth. So the number, the ID, and we have the text. Okay. This is an imbalanced data set. We can see that there are categories for which there are only 4, 6, or 8, and there is one category for which there is thousands complaints. And we want to group them a bit because we have 17, and we can see, for instance, money transfer is also here in a global category. So we want to put them together. The same for instance, credit reporting. This one should be with the first one. And if we do this, we replace, and we end up with something like this. These are the category we want to predict. So mortgage, debt collection, basically financial products. And we can also plot the number of complaints per category. And we see that it's imbalanced with 50%, around 50%. We will see the base rate after in one of the complaints that concern only one category. Okay. Yes, the base rate. So the probability of the most of the class which with the most occurrences. This means if we wouldn't use any algorithm, we would classify everything in this to have the best accuracy, the best possible accuracy, and this means that we have to bit to outperform this rate in order for our model to work. Because if it's not the case, you would have a better accuracy if you assign each new instance to this class. So we run this and we end up with a base rate of around 40% that we have to keep in mind. 40% base rate around. Okay, first using TF-IDF. So I import the logistic regression, train test split, pipeline. This is the same. Basically, this is the same as last lab session. So I do this. I have my tokenizer function. So I pass a sentence and I return a list of token, a clean list of token for which I lemmatized everything. I make everything lowercase. I remove the punctuation and the stop words, and so on and so forth. So this is my tokenizer function. I select the features. My X is the text, so the narrative, and my Y is the label. And I train test splits using a test size of 20% and the random states. This will be the same in the second example, 1, 2, 3, 4. So if I run this, we have our X train of length 2050, 80% of the data, and our Y train is of length. This is why is it the same? I don't know. It should be a mistake. I don't know what. Yes, because it's Y train. It's not Y. It's not X test. I was expecting X test. So this is our X train. Sorry, this is our X train. So these are the complaints, and we want to predict the category Y train. So we define the vectorizer TF-IDF with the parameters. For instance, we have a min TF of 5. We want to have both 1 gram and b grams, and we use the spacey tokenizer function that we defined above as tokenizer. We have a logistic regression for the classification. And if we do this, we gather everything in a pipeline and we train the model based on this. This is to, the time is to time the cell because it will take like one minute something to run. Yes. Okay. I have to go quickly on this, and this is not so good, but okay, so TF-IDF as we saw, and then I can continue without having the results, but I predict for the test set, and then I evaluate the accuracy, so the number of correct classifications divided by the total number of classification. So the confusion matrix you will see. Okay. And basically afterward we will do the same, so the same splits 1, 2, 3, 4, and we will see this with the doc2vec, so this word embedding methods based on neural network. It's the best time to ask questions if you have some. Okay, it took like 1 minute 30 seconds. Yes, please.
Sorry, may I ask about the groups again? Also, I missed the first part of this lab, so maybe you already said it. But how are the groups for the project made, or will they be assigned? How does it work?
I don't know. I really don't know. This makes Ahmad, and I'm not responsible for it, so I don't know. You can ask Ahmad.
Okay.
I really don't know if you have the choice or not. I don't know.
Okay, thank you.
Okay, I already ran this because it took also like 2 minutes, and I explained this now. So we end up with an accuracy of 74%, which is better than the base rate, which was 40%. So we are fine. So we did better than classifying everything is in the most predominant class. And we can see that the confusion matrix is here, and we have so the base this line represents true classifications, and we have a lot of true classification on this category. This should be the category on which had like 1,000 instances. Okay, so accuracy of 73.73%, which is not so bad for given the problem. Okay, and now very quickly the same thing using doc2vec. So this word embedding, this representation, this does the same as the word2vec. So similar documents, similar complaints will have a similar vector representation in this case. So we will, and then this should be useful for the logistic regression to classify. This should be useful. Okay. And as before, the only thing that changes is the methods. I use the same tokenizer, so we have the same tokenizer function. So we have the same token in each complaint. We also have the same split as before with the same random states. So if we have the train, we had like 949 was the first, and in the example also was 949. So we have the same splits, train and test sets. This is to use all the core of my computer, and we use the doc2vec. I don't have time to specify the parameters, but you have the documentation on the link, and also here if you want to use it. This should be very useful for the project. And if I do this, so we use a vector size of 30. So each complaint will be transformed in a vector of size 30. And yes, this is the algorithm we want to use. But you can look at the parameters on your own. This is, for instance, the number of epoch of the neural nets. This is my number of cores, and so on and so forth. This is, for instance, also the minimum count. So this number of occurrence, minimum number of occurrence of the words in the to be taken into account. And I can show you this will be interesting. How does it look like? Basically, this is only a function to dzip the format that I did. So I have such a format, and we have the words, and then we want the tag, and we want to separate them. This vec for learning. And this infer vector, you take the words and you infer the vector from the words, because you train, of course, you have to train your doc2vec model on the train, and then you have to infer the vector for the tests, basically for all, but also for the test, as shown here. Okay, and you end up with vectors. So this is my complaints. This is my first complaint. This is a vector of size 30 because I specified the size. This is the second one, and so on and so forth. And if we fit and evaluate a logistic regression, again, this is the same algorithm, everything is the same. We end up with a slightly better results. In this case, you may have another result because it's based on neural nets or optimization. And I think that's it for this. Yeah, I'm sorry that it was a bit quickly the end. If you have any question, you can always ask. But you have to finish before 15, and we also want a break maybe. So that's it for the doc2vec. There was something. Yes, of course, if you have more instances, since it's neural nets, if you have more instances, you will get normally a better prediction with this. This is maybe the data is too small to make a huge difference between the two, TF-IDF and Word2Vec, because TF-IDF works well with small data sets, and this works better with the doc2vec works better with greater data sets because it's based on neural nets. And what you can also do is trying to tune these parameters and see if you can improve, for instance, the accuracy. There is a question. There is a question 3. Okay, they send me the. Yes, there is a question. Would it be possible to share the notebook for assignment 1? We can do this. I will ask the professor if he agrees to post it, but I think it will be posted. Okay. Okay, so I am done with this lab session. I hope it was clear. Sorry that we didn't have much time on this part, on this very interesting part, but I think we have. You can read this. You can read the documentation. This should be fine. And this is in your project. I recommend trying to use this Doc2Vec because it is very powerful. If the project, yes, the project is on text analytics. Okay. So don't forget to send me your code for the exercise, for the participation exercise, and we will see each other next week. I wish you a nice afternoon, evening, a nice class with the guest speaker. And if you have questions, I stay to answer the questions. Okay. So see you next Monday. Ciao. Okay, so there is a question. When can we know the grades for the assignment 1? My part was to give you a grade for the bonus question. I did this today, and Ahmad is doing the rest. This take a bit of time because this is comparing your versions to see if there is too big similarities between what you submitted. So it will take a bit of time. I saw there are notes on the quiz for the assignment. Is it the final notes? I guess yes. I guess yes. But I think and I hope that Ahmad would send feedback. Maybe, I don't know. We just have to send you our code by message for the exercise. Yes, you can send me it. You can send it to me on Slack or via Zoom in private, but better on Slack. I got 8 out of 10 for the quiz. However, I'm sure I did everything correctly. I can check this, but if you got 10 out of 10, it means that you have not everything correct. I don't know. But if there are problems for one question, we see this and we if there is problems, we correct this. So we will. I don't know if Ahmad already reviewed the quiz. How can I know why I did not get points? I will ask the professor if we can post the solution so that you can check. Do the bonus points count to it there? Yes. For process text in process text print. Yeah, just to have only the first 20. David, just to have the first 20. to see only the first 20, because if you print everything, you will have yeah, everything, and we don't want to have everything because it takes a lot of space. You cannot see the quiz. Yes, I will. I'm not responsible for the quiz, so you have better to ask Ahmad or the prof. But Ahmad is responsible for it. I was only responsible to grade the bonus question, what I did today. Another question, remark about the participation during class. I think that's not really fair, as it was not specified at the beginning of the semester. What if someone planned working shift based on the initial schedule? What is not then submit on the same day? I know. Yeah, this is the way of working, Pierre. This is the way of working of the professor. So yes, I don't know what to think about it. I'm only like the teaching assistant. So the professor decides on the way he wants to organize the class.